Hi, Reham. Now, I will distribute this questionnaire. This is the second worksheet from this chapter. Okay? Our second worksheet. We have discussed the second one, that's actually third one. We will discuss that later. So you have now three question papers from this chapter, three worksheets from this chapter. The first worksheet we have almost completed. We have almost completed the first chapter. Let me close the door. Yeah, we have almost completed the first chapter, first worksheet, and now we are looking at the second one. We are looking at the second worksheet, right? Second worksheet. Joseph, can you identify the second worksheet? Can you see the second worksheet? Hey, Joseph, can you?
Yes, sir. Yes, sir.
Yeah, can you see the second worksheet in our group? Worksheet number 2.
Yes, sir.
Okay. We will be discussing this worksheet. We will just discuss three questions in it. After that, we have to discuss another worksheet also. Then we have to move to the next chapter, current density also. This is a very big day for us. Just try electric potential and potential energy. This is from that part. Electrical potential and potential energy. This question, the questions are from that part. Okay? Just read the first question again. Most of the time, the problem with us will be not understanding the question, not identifying the problem. That will be our problem most of the times. Just try to understand the question. What is the question? Just read the question. 4 point charges are placed at the corners of a square in two ways. There is two squares and there are 4 charges. What are they? Plus Q, minus Q, minus Q. Can you see that? And they are arranged in two fashion. Two methods. Will the electric field and electric potential at the center of the square be same or different in two percentages?
So this worksheet is
yeah. This is the second worksheet, electric potential and potential energy. Okay? And why? You have to state also why is that happening. That's our question. Just understand that question. Understand that question and tell me what that question actually means. Read the question. Read the question. Identify the problem and give me an idea how to solve that.
it will be different because the charges are
Yeah. The charges, you have only 4 charges with you, right? We are discussing worksheet 2. Worksheet 2. How many charges do you have? Only 4. Only 4. One is plus Q, the other one is plus Q, and there is minus Q and minus Q. And you can configure them in 2 different methods. And one method is two different methods are shown there. Can you see that? This is a square. And in the first method, this minus Q and minus Q is here. And this plus Q and plus Q is here. Can you see that? This is the first method.
Yes,
right? We are discussing the worksheet number 2, right? Worksheet number 2. Electric potential and potential energy. Yeah, I'll give you that. Electric potential and potential energy. Let's see.
Sir, connection is a little bit bad, so I can't see the board correct.
I didn't get it. What was that?
So the connection is
Network has a
bad, so I
problem.
can't see the board clearly.
Okay. I'll try to rectify it. Give me a minute. What about now, Joseph? What about now? Can you see clearly?
Yes, sir. Yes, sir.
Yeah. Mark this as worksheet 2. On the top of it, mark this as worksheet 2. Do that. Mark this worksheet as worksheet 2. If there is any problem with the network, please let me know. Betsy, Joseph, please let me know if there is any problem with the network. Betsy, what about now? Is it clear now, Betsy? Okay, then we will continue. We will continue. Just read the first question from the worksheet 2. Arfan, read it. Natasha, read the question. Everyone, read that question and understand what you need to find. What is that question? You have two configurations. One configuration is like this, and second configuration that is given in the question. The second configuration is also given in the question. There is minus q and there is minus q. No, there is plus q. And here you have plus q and minus q. This is the second configuration. This is what? Hey guys, this is what? This is the second configuration. And what is the question? Will the electric field and electric potential at the center of the square be same or different? At the center, there is electric field and electric potential. They are asking for you to find the electric field and electric potential. What is the name given for electric field? That's E. The notation, the letter that is given for electric field is what? That's E. And potential. For potential, which is the letter? That's V. And they are asking you to find or to compare what is the electric field and electric potential at the center of both the squares. Right? Right? And let me tell you, these both configurations are different, right? Right? They are different. That means the electric field and the electric potential can be different. There is a chance for that. Can you give me any idea how to find the electric field at this center or electric potential at this center? Can you have any idea? Can you give me any idea about how to find this electric field and electric potential?
Sorry.
Charge. There is
Depending
charge.
different.
And electric potential and electric field is depending on the charge, right? Both of them are depending on the charge, right? Okay. Then look at the first question. Look at the first configuration. This is the first configuration, right? This is the configuration given in the question. So I am taking the first configuration. This is minus q here, plus q here, another plus q here. There is 4 charges. They are arranged in this way, and this is the center of this. Okay, we have to find the electric potential and the electric field at this point, right? Now look at this figure. What is the nature of electric field? What is the nature of electric field due to a positive charge? No, that's not positive. Electric field, in electric field, there is no positive electric field and negative electric field. No. There is no positive electric field or negative electric field. That's that. Electric field can be away from the charge towards the charge. For positive charge, electric field, nature of electric field will be what? Away from the charge. Right? Away from the charge. Here you have a positive charge. So the electric field due to this positive charge will be like this, away from the charge. Is that okay? And here you have another positive charge. So the electric field due to this positive charge will be away from the charge. Is that okay? Okay. What about negative charge? Electric field will be towards the charge. Which are the negative charges here? Minus q and minus q are the negative charges here. So the charge due to this minus q, electric field due to this minus q charge will be towards the charge. Towards the charge. That means again it will be in this direction. Again it will be in the same direction. Right? Towards the charge. And what about this one? Electric field due to this minus q will be how? Towards the charge. It will be again like this. Right? I will draw it here. I will draw it here. It is like this, right? Right? And this is the exact figure. This is the electric field due to plus q. This plus q. This is the electric field due to minus q. Is that okay? And this is the electric field due to this plus q. And this is the electric field due to minus q. There is no positive and negative in electric field. There is no positive and negative in electric field. Is that okay? But positive charge, for a positive charge, electric field will be away from the positive charge, and for a negative charge, electric field will be towards the negative charge. Is that okay? Now you have this idea. You have this thing. What is it? What will be the angle between them? What will be the angle between them? These are the diagonals of a square, right? These are the diagonals of a square. If you want to correctly understand that, I will redraw this square. That's a square. Let it be a square. And what will be the diagonals? Diagonals will be like this, right? For a square, diagonals will be like this. That means the angle between the diagonals will be 90 degrees. Right? The angle between the diagonals will be what? 90 degrees. Is that okay? That means the angle between them will be 90 degrees. Angle between them will be 90 degrees. Now, just look at this. This electric field is a vector. We know that. Electric field is a vector. If there is two vectors acting in the same direction, you can add them. Right? You can add them. That means the figure can be slightly changed like this. Right? Here on the right side, there will be E plus E. What is that? 2E. This electric field is due to plus Q and minus Q. Their magnitude is equal. That is Q. The charge will be plus Q and minus Q. But the electric field is equal in the both cases. For the positive case and negative case. That means this E and E will be what? That will be 2E here and 2E here. Can you understand that? Yeah. Both of them will be 2E and 2E. Is that okay? Now you can find the total electric field. How can you find the total electric field? Resultant. How can you find the total electric field? Resultant. What will be the resultant of that? They are two sides of a parallelogram. You can use parallelogram law of vector addition. Parallelogram law of vector addition. What was parallelogram law of vector addition? Resultant is root of c square plus q square plus 2pq cos theta. But if theta is 90 degree, that's only root of p square plus q square. Like this. If theta is 90 degree, what was resultant? What was resultant? Root of p square plus q square. Because cos 90 will be 0. Cosine will be 0. That whole term will be gone. Then the resultant will be root of b square plus b. Can you understand that? Then what is the resultant here? What is the resultant here? E. What will be E? That's net electric field. Net electric field. Net electric field. What will be net electric field? Yeah, root of this term. There is this term and root of 2e square plus 2e square. Root of 2e square plus 2e square. What will be the final value? What is 2e square? 2e square will be 4e square, right? 4e square plus what is 2e square? That's again 4e square. That means 4e square plus 4e square. What will be the value?
8.
That will be 2 4e square. 2 4e square, right? 4e square plus 4e square. 2 4e square, right? Then this is electric field. Net electric field. Net electric field. How can you find the final value? Net electric field will be this is there is a square root for 4e square. Square root for 4e square. What is the square root of 4e square? 2e. Square root of 4 is 2, right? 2. So 2. Square root of e square is e. So 2e. 2e. Square root of 2. Just write it like that. Square root of 2. So this is the net electric field. This is what? This is the net electric field. Got it? Net electric field. And how can you find a total potential at the center? Total potential at the center. Total potential at the center. How can you find the total potential at the center? How will be that? Total potential at the center. Total potential. Just give it a V. Total potential. What will be the total potential? There will be potential due to this plus Q. Right? This plus Q will be giving a potential at the center. Is that okay? And there will be a potential due to this minus Q here. Right? And there will be plus Q here. Potential due to plus Q. And at the same point, there will be potential due to minus Q also. Is that okay? So what will be the total potential at the center?
Here.
Total potential at the center. What is the equation for potential? 1 by 4 pi epsilon naught. Can be taken as K. For our convenience, take it as K. Then what is that? K Q by R. That's potential. There is no R square in potential. In the equation of potential, there is no R square. K Q by R is the equation. Is that okay? Is that okay? So what is the potential due to plus Q? Potential due to positive charges. Potential due to positive charges. Positive. Potential due to negative charges. Negative. Say it again. Potential due to positive charges. Positive potential. Potential due to negative charges. Negative potential. Is that okay? So for this potential due to plus Q will be what? 1 by 4 pi epsilon naught is K, right? K Q by R. Just take this direction as R. Take this distance as R. Then K Q by R is the potential due to plus Q. Now what is the potential due to this plus Q? I will give a name here. A, B, C, D. Then what is the potential due to another plus Q? Plus K Q by R, right? Then what is the potential due to minus Q at the C? Minus KQ divided by R. The distance will be same, right? The distance will be same. If the distance is to the center, so the distance will be same. Minus KQ by R. Then what is the potential due to minus Q at D? That will be minus KQ by R. Got it? Yeah. Then what is this? It will be 0. So potential at the center will be 0. Potential at the center will be 0. The potential at the center will be 0. I will just put the values, the final values in a box. I will put the final values in a box. Is the First figure okay, first configuration is okay, right? For everyone,
Yes.
then take it out. Take a note of it. That's our first configuration. Take a note for it. I will repeat the question. I will repeat it. You write. You should write. I will repeat it. The question is you are given 4 charges, plus 2 plus q's and 2 minus q's, and you are asked to, what are you required to do? You are asked to find the total electric field and total potential, total electric field and total potential at the center. Now you can do that by just understanding at the center there will be electric field due to this plus q and electric field due to this minus q, right? So we are just finding the electric field due to plus q and electric field due to minus q. Will be that? Is that okay? Is that better?
Yes.
What will be electric field due to this plus q? That will be away from it. Away from it. Electric field due to minus q will be towards it. So that the electric field will be in the same direction. Both the electric fields will be in the same direction. If you are just looking at it, you can find another figure there, another idea there. That is, electric field is acting in the same direction on one side and the same direction on the other side. The angle between them is actually 90 degrees. So you can use parallelogram law of vector addition to find the resultant. What is the resultant? Resultant will be E root of, that's net electric field, root of 2e square plus 2e square, that is 4e square plus 4e square, that is 2 into 4e square. Is that okay? 2 into 4e square. So 2e root 2 is the net electric. So that's okay. Then the next one, total potential at the center. What is the total potential at the center? That's potential due to positive charge is positive, potential due to negative charge is negative. So the first potential will be k cube by r, k cube by r. Second potential due to plus q at b, that will be again plus k cube by r. Then potential due to c, or potential due to minus q at c, that is what? Minus k cube by r. Then potential due to minus q at d, what is that? Minus k cube by r. Just add them, you will get 0.
But we also have to explain why.
This is the y. Y part is this calculation, right? Y part is this calculation. They are asking why you have these two values are different in different configurations, and why. Y part is the calculation of it. That will be enough.
5 marks, 4 marks.
It's actually no, I don't have the mark of it. Maybe 5 mark. Okay, is that okay? Can I move to the next question? No, sorry, the second part of the question. There is a second part in it. Just try to do that. Arfan, Abel, if you have completed it, try to do the second part. Try to find the net electric field due to at this point, due to these charges at this point, and net potential at this point. Try to do that.
Did you understand first configuration? What about second one? Yeah, second one. This is plus 2 plus 2. Electric field will be away from it, away from it. Here, it will be towards it, towards it. What will happen? Just give me network. You can just give me that is this vector is C, and just add a few vector, and you can say the total electricity will be but one more made potential is 5 to that potential.
Is that okay? Can I move to the next part? We have the first one, and now we are going to see the second configuration. Look at the second configuration. Look at the second configuration. What can you see here? Electric field due to positive charges away from it, right? Away from it. That means electric field due to this positive charge will be away from it, right? And electric field due to this positive charge will be away from it like this. and it will be towards it. Towards it. This again towards it. So net electric field will be what? Net electric field will be what? No, it will be like this. One electric field in that direction, other electric field is in this direction, right? One is that direction, this direction. What will happen? Both of them are equal. Both of them are equal. Then that means here you have E here, E here, E here. What is net electric field? Net electric field will be what? They are in opposite directions.
Zero,
Right?
sir.
This will be cancelled with this one. This will be again cancelled with this one. That means net electric field will be zero. Net electric field will be zero. Can I erase this part?
One line is towards the point.
Which one?
One of the lines is towards the middle.
Which line?
One of the diagonals. One of the diagonals.
Oh, okay. The arrow.
Then
No.
towards the center.
Towards the center. This is towards the center. It's actually towards the center, but I.
The other one.
Other one,
Which one? This one.
towards plus Q. Yeah.
This is actually towards the center. Right? This is actually this one. I will give the colors. This E is this E. Is that okay? This is vectors. Without changing the angles, you can displace them. Like that. This is vectors. So without changing the angles, you can displace them. Then that will be like this. This E is this E. Is that okay? So net electric field will be zero. Net electric field will be zero. And try to find net potential. What is the value of net potential? Total potential. What is the value of total potential at the center? Total potential at the center, V. How can you find V? Just give names for each vertices. A, B, C, D. What is potential due to plus Q? K, Q by R. It has no direction. Potential is scalar, right? What is potential due to minus Q at B? Again, minus KQ by R. Potential due to plus Q at C? Plus KQ by R. Potential due to minus Q at D? Minus KQ by R. Then what will be the total potential? Zero. Total potential will be zero. Now you have total potential is zero and net electric field is zero in the next case. In the next case. Just compare them in a diagram. Just compare them in a diagram. What is that diagram? What is the question? Look at the question. Look at the question again. Look at the question again. Will the electric field and electric potential at the center of the square be the same or different in two configurations? Electric potential is same in both the cases, but electric field is different in both cases. That is our last diagram. Just write it. Electric potential will be different in both cases. Electric potential will be different. Hi Neha. We are discussing the worksheet number 2. We are discussing worksheet number 2. Okay, that's in the group, our WhatsApp group. This is first question we have discussed. Okay. What about the next second configuration? Just looking at the second configuration, at the center there will be electric fields in opposite directions, right? And this will be cancelled with this one. This electric field will be cancelled with this electric field. So the net electric field will be zero. And at the center, there will be potential due to plus Qs and minus Qs. Potential due to positive charge is positive. Potential due to negative charge is negative. So if you are adding the potential, you can add potential, right? You can add potential just like numbers. There will be positives in it and negatives in it. Is that okay? If you are just adding the potentials, you will get potential at the center is zero. Potential at the center is zero. Can I move to the next question? The second question, look at the second question. Let's see. Can I move to the next question? Let's see. Can you hear me? Let's see. Yeah. Okay. Read the next question. Second question. What is the second question? Second question. Read it. Read it. The two graphs drawn here show the variation of electrostatic potential V with 1 by R. What is 1 by R? 1 by distance. What is 1 by R? 1 by distance. That is 1 by distance. Okay. For 2 point charges Q1 and Q2. Q1 is below, Q2 is above. What are the signs of these two charges? What are the signs of these two charges? There will be sign for the charges. Positive sign and negative sign. What will be the sign of Q1 and Q2? That is the first question. Which of the two charges has a larger magnitude and why? That is the question. Read the question again. Read the question again. Understand that question. Read the question again. Understand that question. Read the question. Read the question. Read the question. Understand it. Try to understand it. Try to understand it. Which is Q1 and which is Q2. This is Q1, this is Q2, and this is V. You are writing the answer in the notebook, right? You are writing the answer in the notebook, right? And just write the above or the first part, worksheet number 2. Worksheet number 2. Have you written it? Worksheet number 2. This is the idea. This is the given graph. What is this graph? This graph is between V and 1 by R. What is this V? What is V? V is potential. What is 1 by R? 1 by distance. 1 by distance. Just look at the equation. What is the equation? V is equal to 1 by 4 pi epsilon naught Q by R is the equation. Right? Right? And we can see from here V is inversely proportional to R, or V is directly proportional to 1 by R. Or V is directly proportional to 1 by R. That's why this is a straight line. That's why this is a straight line. We have seen the graph like this, potential and distance. How was that graph? What is the shape of that graph? Rectangular hyperbola, right? This graph was like this. But this is a straight line. Why is this a straight line? Because V is directly proportional to 1 by R. That's it. Right? That is, V is directly proportional to 1 by R. That's why this graph is a straight line. Did you understand that? Now, what is the first question? Look at the first question. What is the first question? What are the signs of these two charges? And we have an idea about electric potential. What is that? Potential due to positive charge is positive. Potential due to negative charge is negative, right? Yeah. Now this is positive y-axis. This is negative y-axis. So this is positive potential and this is negative potential. Right? This is positive potential and this is negative potential. So in the charges Q1 and Q2, what is the positive charge? What is the negative charge? Yeah, Q2 will be positive charge. Q1 will be negative charge. Did you get it? Q1 will be negative charge. Q1 is negative charge. What about Q2? Q2 is a positive charge. Did you understand that? Yeah. So that's the first answer. First answer to the first question. And which of the two charges has a larger magnitude and why? Which has a larger magnitude and why? Which of the two charges? They are asking for the charge. They are asking for the charge. Which of the charge has a larger magnitude and why? That's the question. Which has a larger magnitude? Just look here. Just look here. Just look here. How can you find the charge from this equation? How can you find the charge from this equation? Just take this as K. Then KQ by R is the equation, right?
Yeah.
I am trying to solve the second one. KQ by R is the equation, right? So what will be Q from here? Q from here.
K by V R.
Okay, let K there or KQ. What is KQ here? V
We
R. V into R. Q will be what? KQ will be what? V into R. Right? V into R. What is the slope of this figure? What is the slope of this figure? What is slope of this figure? Slope is dy by dx. You know that? Slope from a straight line graph is dy by dx or y by x or dy by dx. Is that okay? Or tan theta. You know what is slope? Slope is tan theta. What is tan theta? Opposite side by adjacent side. What is that? Y by x. Right? That's y by x. If you are taking the slope of it, it will be like this. The theta will be here. Theta will be here. And this is what? This will be y and this is x. Did you get it?
Yeah.
Now the slope y by x. Y is what? Y is b divided by what is x? X is 1 by r. Then what is that?
Yeah.
Yeah. V by 1 by r. R will be coming to the numerator. Then that will be VR. Yeah. Now the slope is VR. The slope is VR now. That means what is this VR? What is this VR from this equation? VR from the equation. VR is directly proportional to Q charge. That means if VR is greater, if the slope is greater, the value of charge will be greater. Which line has greater slope here? Yeah, Q1 has greater slope here. Right? Here Q1 is more inclined. Q1 has greater slope here. Right? So then that's it. Slope is equal to VR. Slope is magnitude wise equal to what? What is it? Equal to, that's equal to charge, right? That is magnitude wise equal to charge or proportional to charge. Slope is giving you an idea about the charge. Slope is giving you an idea about the charge. So if the slope of Q1 is greater, then Q1 has larger magnitude. That's the answer. Slope of Q1 is greater, right? Slope of Q1 is greater. Slope of Q1 is greater. Slope is equal to VR, right? For that charge, VR is equal to charge. So slope of Q1 is greater. That means that is Q1 has larger magnitude. But okay, Q1 has larger magnitude. Q1 has larger magnitude. Q1 has larger magnitude. Now that's our second question. That's our second question. But okay? Can I move to the next question? Is this question okay? Okay for you all? Betsy, Joseph, Neha. Is this question okay?
Yes, sir. Yes.
Is it okay, Joseph? Is it okay, Betsy? What about you, Neha? Did you get it? Neha, okay. Sure. Read the third question. Guys, read the third question. Read the third question. What is the third question? Read the third one. Third question is a little bit complicated question. Just try to understand that question first. We will look at the answer then. Try to understand the question first. The question is a little bit complicated.
Yeah.
Third question. Read the third question and give me an idea what is the third question saying. That Joyita, what is third question saying? Don't read it. Give me an idea. What is it? What is it saying? There is a verse there. There is a plus charge.
The radius R.
Capital R.
Small r.
There is actually two spheres, two concentric sphere. What is concentric sphere? One sphere. Both the centers will be the same. That's concentric sphere. Both the centers will be same. That's concentric sphere. If I want to draw a concentric sphere, that will be like this. This is the larger sphere. Inside that larger sphere, there is another smaller sphere. There is another smaller sphere. They are what? They are what? They are concentric. What is concentric means? Like this. One center. Right? One center, two centers. Concentric. And what is the radius of them? R and capital R. Capital R is greater than small r. That means capital R will be this one and this is small r. That is the idea. Okay. And such that the surface charge densities are equal. Surface charge densities are equal. That means surface charge density of first sphere, I am taking it as sigma 1 and sigma 1 is equal to sigma 2. That's given in the question. Find the potential at the common center. That is the question. What is the potential at the common center is the question. Is the potential at the common center? That's the question. How can you solve this? How can you solve this? There is actually two ideas. Just concentrate on what I am saying. There is two ideas in this question. What are the two ideas? The whole charge is what? The whole charge is Q. The whole charge, the charge is what? The charge given in the question is what? The charge given in the question is Q. That Q is distributed over both of these shells or both of these spheres. A charge Q is distributed over two concentric hollow spheres. That means what is the sphere on large? Sorry, what is the charge on larger sphere? What is the charge on smaller sphere? Give me that. Is that Q? Charge on larger sphere. What will be that? Is it plus Q? So then what will be the charge on this one? This small sphere, what will be that? No. No. That's why I am always constantly saying you read the question again and again. Read the question, read the question. That Q is distributed over both of these spheres. That means no, both are not Q. The whole Q is distributed over them. I have 10 apples, I am distributing that among you. How many apples do you get? 1, 2, 3, 4, 5, 6, 7, 8. Right? Like that. Got it? So this Q is distributed over them, over both of the spheres. That means there is Q1 here, there is Q2 here. Q1 is the charge of sphere 1. Q2 is the charge of sphere 2. Then Q will be what? Yeah, Q1 will be Q1 plus Q2. That's the first idea. That is the first idea. What is the second idea? Sigma 1 is equal to sigma 2. Sigma 1 is equal to sigma 2 is the second idea. What is this? Surface charge densities are equal. What is sigma 1? This is the first sphere. This is the first sphere. This is the second sphere. Are you concentrating here? This is the first sphere and this is the second sphere. So the charge densities are equal means what is charge density equation? Equation for charge density is what? Q by A. That means for sigma 1 that will be Q1 by A is what? Area of the sphere. What is area of the sphere? What is area of the sphere?
3 by 4 pi.
No. That's volume. 4 by 3 pi r cube is volume. 4 pi r square. What is the area of the sphere? 4 pi r square. So 4 pi r square. In Q1, in the case of Q1, here. In the case of Q1, what is the R?
Capital R.
Capital R. In the case of Q1, that is capital R. So Q1 by 4 pi R square will be equal to what? Will be equal to what?
Q2 by.
Concentrate here. This is a tough question. Just concentrate here. You need this. This is actually previous question. Previously asked questions, you will be required to write this in exam. This type of question. I am not grabbing this question from air. These all are previous questions. You have to understand that you are going to appear for a public exam. Okay? Just here, Q1 by 4 pi r square. And what is sigma 2?
Q2 by
That will be Q2 by 4 pi
Small
r square. Right? That means this 4 pi will be gone. And Q1 by r square will be equal to Q2 by small r. Which one? Oh, you can cross multiply it. I will be just writing this like this. So this is the idea. And what is the potential at the center? What will be the potential at the center? Potential at the center. What will be the potential at the center? Give me an equation for potential at the center. KQ by R. That's the potential at the center. Right? But there is two concentric spheres. So there will be potential due to Q1. There will be potential due to Q2 at the center. No. Potential due to Q1 plus potential due to Q2. Got it? What is potential due to V? What is potential due to Q1? K Q1 or 1 by 4 pi epsilon naught. That's K. Q1 divided by capital R. Q1 divided by capital R plus. What is potential due to small q?
1 by 4.
Sorry, Q2
1 by
1 by 4 pi epsilon naught Q2 divided by small r. This is the potential, right? But what is the problem? What is the problem is if it is a MCQ question, the option will not be like this. The option will be in another form. We may have to convert this into that form. That is the problem. And the problem here, I will tell you the problem. The problem here is this Q1 and Q2. What are Q1 and Q2? That's not given. That's not given in the question. That is the problem. Yeah. No. This Q1 and Q2 is not given in the question. We are taking Q1 and Q2. The question, they don't know what is this Q1 and Q2. But it is related to this Q, capital Q. So the answer must be in terms of capital Q and capital R, small r. That means the answer must be in the terms of question. In the terms of the question. This is not in the terms of question. Did you get it? Did you get it? Q1 and Q2, we are taking Q1 and Q2. We are taking Q1 and Q2 is equal to capital Q for our convenience. So the answer should not be like this. So you have to convert it. How will you be converting this? 1 by 4 pi epsilon naught can be taken out, right? 1 by 4 pi epsilon naught can be taken out. And inside it, what will be? There will be Q1 by R plus Q2 by R plus Q2 by R. There will be Q1 by R plus Q2 by R. Excuse me. Hello. Shall I go? I'm in class. I'm in class. Can you call me? No, not one. No, what others? Oh, sure. Okay. Look here. Just look at here. Look here. Look here. Look here. What is this? Q1 by R, Q2 by R, right? Q1 by R and Q2 by R. Now you have this Q1 by R square is equal to Q2 by R square. You have a relation between Q1 and Q2 with R and capital. With R and capital. You can find the value of Q2 from here or Q1 from here. Right? Then there will be only one Q1. Can you understand that? There will be only one Q1. If you are converting this Q2 or Q1, what will be that? If I am writing for Q1, what will be the value? Both of them. If I am converting for, if I am taking Q1, what will be the value? Q2 into R square by R square. Or you can take Q2, or you can take Q2 also. Or you can take Q2 also. What will be Q2?
Q1 R square.
Q1. You can substitute for Q1 or Q2. That's the idea. Q1 or Q2. And if I am writing this Q1, I am just writing Q1. I am just writing Q1. I am taking for Q1. What is this Q1? What will be Q1? Q2 into capital R square divided by small r square. Right. Okay, so what will be this? 1 by 4 pi epsilon naught. There is Q1 by R, right? Q1 by R instead of Q1. Instead of Q1, I can write what? I can write Q2. Q2 divided by, sorry, Q2 into R square divided by small r square into 1 by R. Is that okay? Is that okay? This by R can be written as 1 by R. By R can be written as 1 by R. Is that okay now? By R can be written as 1 by R. Plus, what is this?
Q1 by R.
This one. Just multiply this R square to the other side. You will get Q2 into R square by small r. That's Q1. Now you have Q1. Now you have Q1. So you can substitute for Q1. What will be that? Q2 into R square divided by R square 1 by R. And now you can cut this R. Cut this R from this equation. You will be left with what? You will be left with only 1 R on top. 1 R on top. What will be the value here? You don't have to substitute. That is Q2 itself. That's Q2. So that's Q2 divided by small r. That's Q2 divided by small r. Which? This one. Oh. So there is Q2 by R square. Q2 by R. I am taking out Q2 by R square from it. Can I do that? Can do that. So the equation will be like this. I want this Q2 into one side. That's why I am doing that. I want this Q2 to one side. That's why I am doing this. P is equal to, I am just taking Q2 by R square to outside. That will be 1 by 4 pi epsilon naught. Q2 divided by R square. I am taking out Q2 divided by R square. Is that okay? What are you left with here? Inside the bracket, what do you put? Q2 by R square taken out. There will be just one R. Capital R will be below.
R plus
Q2
by root R.
There is Q2 by only one R. Right? If you are taking it again, that will be.
So let's look at it Q2 by R. Yeah, this is Q2 by R. Because if we take Q2 by R square, then there will be no R.
Yeah, that's I'm saying Q2 by R square. I'm taking Q2 by R square. How can I take Q2? How can I take Q2 by R square here? There is only one R in it. If I am taking this Q2 by R square, there will be an R left. Just multiply it. What will give you? What will it give you? Q2 by R square into R. That's the first term. Q2 by R square into R. That one R will be gone. Q2 by R. You will be left with that. What? You will be left with what? This equation. Can you understand this equation?
Yes.
Reham,
Yes.
Gobika, did you understand that one?
Yes.
What did I do there? Natasha, what did I do there? I take out Q2 by R square. I take out Q2 by R square. And what are you left with? There is no problem here. One R will be there. And how can I take Q2 by R square from it? How can I take Q2 by R square from it? There is no R square. I have to give an R though. That's how I can do that. I'm taking out Q2 of Q2. I'm taking 1 by R square. There is only one R. So what do I have to do? I have to multiply an R though. Then I can take out R square. Is that okay? Then this is Q2 divided by R square. Now I
Sir,
have
but if you're multiplying, don't you need to divide?
Joseph,
Sir, if you're multiplying, don't you need to like divide also to not change value?
if I am multiplying,
Don't you need to like divide also to not change value?
I didn't multiply it. I just didn't multiply it. Or you can understand it in other way. Just multiply this into the bracket. What you will get? If you are multiplying this into bracket, you will get Q2 by R square into R plus Q2 by R square into R. What is the answer? You will get Q2 by R square into R plus this R will be gone. That means Q by R. Isn't it the same thing? Isn't it the same thing? Q2 by R square R plus Q2 by R. Are they the same thing?
Yes, sir.
No, I am not doing this one into R divided by R, or that's actually the mathematical operation happening here. Right?
Yes, sir. Yes,
That's
sir.
actually the mathematical operation happening here into R divided by R. Then what is that? This R and the R already below the Q2 is what? Q2 by R square into R.
Yes, sir. Yes,
Now I am taking out this Q2 by R square. Got it?
yes, sir. Yes, sir.
Yeah. So that's it. And I have this equation Q2 by R square. Now there is only one problem. What is that one problem? Q2. What is that one problem? Q2 is that one problem. How can you remove that problem? How can you remove that problem? You can use this equation. Yeah. Q is what? Capital Q. Capital Q is what? Q1 plus Q2 square, right? Q1 plus Q2 square. So what is Q1? Here. Look here. I can remove that Q2. What is the removal of Q2? You can represent Q2 in terms of capital Q. What will be that?
Q minus.
How will be that? Q1 plus Q2, right? Capital Q is Q1 plus Q2. And we have already found the value of Q1. What is the value of Q1?
Q.
What is the value of Q1? Q2 into capital R square divided by small r square plus Q2. Q1 plus Q2. What is Q1? Q1 is this one. Q2 R square divided by R square is. We have to convert this into the term of Q, capital Q. We don't need this Q2 in the answer because we are the one taking that Q1 and Q2, not those who have given you that question. So the answer must be in terms of capital Q, small r, capital R, which is only in the question. Then what is this? How can you do that? How can you find that you don't have you not only have this Q2, have Q2 by R square in it. You have Q2 by R square in it. You can take that out. There is Q and you are taking Q2 by R square from it. If you are taking this Q2 by R square from it, that will be R square plus Q2 is taken out. You don't have that R square there, but you have to do. You have to give an R square. How to give an R? How can you take out Q2 by R square from it? You can take out Q2.
Oh, that's not.
You cannot take out R square. What can you do that? You just multiply an R square there. 5 plus x plus y. That is x plus y. Right? There is x plus y. Or x plus 1 by. X plus 1 by. Like this. X plus 1 by. Can I take x from it? Can I take x from it? I can take x from it. What will be that? Take x, that will be 1 here, and here will be 1. There will be 1 by x. There will be 1 by xy. This is the mathematical operation of taking out something. If you are giving the x inside, that will be x plus x by xy. That will be x plus 1 by y again. Nothing will happen to the equation. Nothing will happen to the equation. Okay? You can take something from, you can take a value from another value, even if that is not there. Just give it there. You can take it. Give the, take it. That's the idea. That's the idea. Got it? Look. Can you understand that? Give one, take that. That's it. So you have taken it, or you have already given it. If you are multiplying that into that, that will be just Q2 again. So you have this Q2 by R square here. What is Q2 by R square? What is Q2 by R square? There is Q, right? Divided by R square plus small r square. Now you have Q2 by R square. You can substitute that value of Q2 by R square. What will be the value? What will be the final equation? 1 by 4 pi epsilon naught. Q2 by R square is what? Q divided by R square plus R square into, what is that? R plus R. Now look at the equation. What is the speciality of that equation? What is the speciality of that equation? That equation only contains capital Q, capital R, small r. Now that will be a term which is likable to those who have given you that question. You understand that? That's why we need to do that. That's why we need to do that. Good idea? Just write the note. Write the note. I will explain it again. This is actually a previous question. Right? But the idea is simple. What is that idea? In the question, they are saying that they have given you a plus q. And they have given you two concentric spheres. And they are saying this plus q is distributed all over that two concentric spheres. That means one charge will be distributed over q1 for the first sphere. And the second charge will be distributed over the second sphere. That's q1 and q2. Right? And the radius of the first sphere is capital R, radius of the second sphere is small r. Is that okay? Is that okay? Now we have two ideas from the question. What is the first idea? Capital Q must be the sum of the charges, Q1 plus Q2. And this idea, second idea, they have given this. Otherwise, we cannot give this equation. They have given this idea. What is this idea? They have given that in the question. Only if that is given, we have to we can find this equation. Otherwise, we cannot find this equation. Right? That's why they are giving you that. So, if there is a question like that, there must be something in that idea, in that given data. That is this one. Surface charge densities are equal. So, you can just get this equation from it. Q1 by R square equal to Q2 by R square. Now you can understand that I am going to use that in my equation. So you are just writing the equation for potential energy at the center. This is the equation for potential energy at the center due to Q1 and due to Q2. Is that okay? Due to Q1 and due to Q2. Got it? And I am just taking the 1 by 4 pi epsilon naught out, then I will be getting this one. But there is a problem in it. Q1 and Q2 are a problem. Q1 and Q2 is a problem not given in the question. We are just taking. So I have to convert that. How can I convert that? First, you need only one unit. Just for Q1 or just Q1 or Q2. Both of them will be okay. I'm taking one. I'm just taking Q1. What is the Q1? What is this? That's Q1. So I can substitute for Q1 there. So I will get something here. And so substituting Q1 there, and I will be getting something here. And I have Q1, I have only Q2 in the equation now. Only Q2 in the equation. Just take out the Q2 and I will be getting Q2 by R square in this equation. Now this Q2 by R square, I can have that Q2 by R square from somewhere in it. Right? That's why I am using this second idea they have given. The second idea they have given is capital Q is equal to Q1 plus Q2. I am substituting for Q1, then that will be like this. Now I have a Q2 by R square in it. Q2 by R square in it also. That's why I am giving you, the answer. The answer, right? So I am taking out this Q2 by R square, that will be Q2 by R square. You are left with R square will be there. And you are taking out Q2 by R square here. I don't have an R square, so give an R square. Give it, take it, give it, take it, give it, take it. Is that okay? Now I have Q2 by R square. If I have Q2 by R square, just let it stay there and take this equation to the other side. Take this term to the other side. Now I will get Q2 by R square is equal to something. Something. That something can be put here. Q2 by R square. Instead of Q2 by R square, that something can be further. Then the equation will be in the term of capital Q, capital R. You understand that? Only by just I'm teaching you, you will not understand this.
Yeah.
You have to do it. That's the only method to understand this type of question. This is a pattern. This is a question pattern. They can ask this type of questions from it. So you have to understand how to do it, not just by heart. You cannot by heart. By hearting this type of question and its solution is not the idea. It's not the solution. You cannot study that like that. This is physics. You cannot by heart any question. You have to understand that question. Did you understand it? That's the idea. The answer should contain what? The answer should contain what is in the question. Can you understand that? The answer should contain what is in the question, not what you have given for your conveniences. Understand that?
Yes.
So you have to practice this question, this particular question. Can you do that? We'll
Sir,
be
Can you explain?
we'll be stopping the worksheet 2 here. We'll be doing exemplar questions after the break. Okay? I will just take 3 questions from the exemplar questions. That will be enough for us. Then I will be going to the third chapter. Okay? Just take a small break. Betsy, Neha, Joseph, all of you, you can take a small break. Yeah, Betsy, tell me. Yeah, I will do that. Others, you can take a break and be here at now it is 5:40. Be here at 5:50. Even if you are here or you are not here, I will take the class. Okay? Be here at 5:50. 5:50. You have 10 minutes. Nice. Thank you. Betsy, I will explain it again. Just look at the question.
So
Look at the question. All of us can take a break. Look at the question. I will read the question again. A charge Q is distributed over 2 concentric hollow spheres. That means they are giving you a Q charge and it is distributed over 2 spheres. One sphere is Q1, the other 2 spheres. Take it as 2 spheres and of radii R and capital R. There is a small spelling mistake in that question. Small r and capital R. You have to take it as small r and capital R, right? In the question, both of them are small r. That is actually not correct. That's wrong. And capital R is greater than small r. That means the larger sphere has a radius capital R. Is that okay? Then such that the surface charge densities are equal. They are saying the surface charge densities are equal. That means the surface charge density of first sphere and surface charge density of second sphere is equal. That's the question. Find the potential at the common center. Now this is a question. There is a common center. I will explain completely. There is a common center. What is the common center? This is the common center, right? This is the common center. There will be a potential at the common center, right? You can find that potential. How can you find that potential? The very simple equation. Potential at a point due to a charge. What is the equation? 1 by 4 pi epsilon naught charge by distance. Or it is in the case of a sphere, charge by radius. Is that okay? So you have two charges here. You are taking that as Q1 and Q2. You are taking it as Q1 and Q2 in such a way that this capital Q will be equal to what? Both of them add Q1 plus Q2 is capital Q. Got it? Q1 plus Q2 is capital Q. Okay, now there will be potential due to Q1 at the center, potential due to Q2 at the center. So you can add them to find the total potential. That will be 1 by 4 pi epsilon naught due to Q1, that is Q1 by capital R, due to Q2, that is 1 by 4 pi epsilon naught Q2 by R. This is the equation. Now we can take out this 1 by 4 pi epsilon naught because it is common. I am taking out 1 by 4 pi epsilon naught. So inside the bracket, I have Q1 by R plus Q2 by R. Now this is the answer, right? This is the answer. This is itself the answer. But there is a slight problem in that answer. What is that problem in the answer? There is Q1 and Q2 in the equation. But the Q1 and Q2 is not given by them in the question. You have to convert that into something they have given you. What is that? Capital Q. You have to convert that into capital Q. How can you do that? How can you do that? There is Q1 and Q2. So first you need to convert this into only one term. Either Q1 or Q2. Both of them will be okay. Both of them will be okay. Both of them will be okay. The final result will be the same. I am taking this Q1. I am taking Q1. What is Q1? Q2 into R square divided by R square, that is Q1. So I am writing for Q1, that's Q2 R square by R square here, into 1 by R. Into 1 by R is this one, divided by R, that's into 1 by R. Okay, then there is Q2 by R also, Q2 by R also, and this R square and R are gone, there is only one R. There is only one R now left. Is that okay? Now look at the equation. What happens here? There is only Q2 R divided by R square, Q2 by R. Right? Now I am taking out this Q2 by R square from it. Q2 by R square from it. Then if I am taking this Q2 by R square from it, you will be left with only R here. See, only R here. That is this R. Only R here. And what is the other one? That will be Q2 by R square. You have to take out Q2 by R square. But there is no R square in it. So what do you need to do? Given R, take R square out. Give an R, take R square out. That's the idea. So you are giving an R, taking R square out. So that will be Q2 by R square. You are giving an R. That's R. Then capital R plus small r is there. Now just look at the equation. Looking at the equation, there is Q2 by R square in the equation. Q2 by R square in the equation. Q2 by R square in the equation. So you have to convert this Q2 by R square in terms of Q. You have to convert this Q2 by R square in terms of Q. How can you do that? You have an idea that is given in the question. That idea is capital Q is equal to small q1 plus small q2. Can you understand that? Small q1 plus small q2. Then what is q1? What is q1? Where is q1? This is q1. This is q1. So you can substitute the value of q1 into that equation. Then that will be q2 r square divided by r square plus q2. Now you have only q2 there. Not only q2, there is actually this q2 divided by r square is there. Q2 divided by r square is there. Right? That's more convenient for us. So q2 by r square can be taken out. If you are taking out q2 by r square as a common term, you will be left with only r square here. But there is no r square here. You can take out Q2 by R square, but there is no R square in it. So you have to give an R square. Then you can take an R square from it. Can you understand that? You have to give an R square, take the R square divided by R square from it. Give an R square, take divided by R square from it. That's why this equation looks like this. So Q2 R square divided by R square, you are giving it a R square and multiplying and dividing it R square. That's actually happening here. R square divided by R square. So you are taking out this R square, you will be left with an R square. Okay. And what is this Q2 by R square? You can have this Q2 by R square from this equation. What is Q2 by R square? You have Q here and take this term to the other side. You will be getting R square plus R square. That will be Q by R square plus R square. That is Q2 by R square. Substitute that value here. This is the value. This is the Q2 by R square. You are substituting it. Q2 by R square. You are substituting Q2 by R square in terms of Q. In terms of capital Q. Now you have only an equation with only capital Q, capital R, small r in it. Now these are in the terms of what is in the question. These are in the terms of what is in the question. Now you can have this answer. This will be an answer, right? If you are taking for Q1, this will be the answer. If you are taking for Q2, the answer will be, if you are taking for Q2, that will be Q1 into R square divided by R square, right? There is a slight change. Q1 into R square divided by R square. Even if you are doing this practice, you will be getting the same result. Even if you are taking Q2 in terms of Q1, you will be getting the same result here again. Okay, that's the idea. That's our idea. Did you understand that? Let's see. What about now? You have to practice it again and again. How many times you are practicing it? That many times you will be better in that type of questions. In that type of question only. Right? Then just take a small break and be here after some time. Okay? Can we continue? Betsy, Neha? Are you there? Betsy, Neha? Are you there? Betsy, Neha? Are you there after the break? Okay. I will bring the others. Can we continue?
Yeah, but they're gone.
Okay.
Yeah, probably he's taking order and then-
We are looking at electric potential. Electric potential. Assembler questions. Electric potential assembler questions. Do you have this worksheet with you? Do you have this worksheet, this particular worksheet? Electric potential assembler questions. Some figures will be in it. You didn't get it. Abel, do you have that? Assembler questions?
Yeah, I think so.
The worksheet that I gave you in the last class. Do you have that? The assembler questions?
Yeah, this one.
No, that's. Do you have that, Tovia? Assembler questions? Right. Then look at the first question. Read the first question. Read the first question. Read the first assembler question. Read the first question. What is the first question? A cube. A cube. What is the first question? A cube.
Side B and not.
A cube of side B has a charge Q at each of its vertices. What are they saying? There is a cube, right?
Yes, sir.
There is a cube. There is a cube, and in a cube, in that cube, the first question. Then the next one sheet. Okay, third one. Cube of side B has a charge Q at each of its vertices. How many vertices has a cube? How many vertices are there for a cube? Only six. No, 1, 2, 3, 4, 5, 6, 7, 8. There will be 8 vertices, right? 8 vertices. That means there will be a charge here, one charge here, one charge here, one charge here, one here, and one here. There will be 8 charges, 8 Q. 8 Qs will be there. One Q is here, another Q here, another Q here, another Q here, Q here, Q, like that. There is another Q. This is the setup. This is the setup they are asking for in the question. Determine the potential and electric field due to this charge array at the center of the cube. You have to find the potential and charge, the electric field at the center. We have already seen such a question, but only in the case of a square. Now this is a cube. Now this is a cube. You are asked to find the potential and electric field at the center of the cube. If you have given 8 charges and 8 charges is distributed in the vertices of the cube. How will you doing that? How can you do that?
We don't know the sign.
Side of it.
No, we don't know the charge. I mean, like positive or negative.
No, you don't know what is that charge. A cube of side B has a charge Q. That only. That's only the data that is given to you. That Q is positive. It can be positive or negative. You don't know that. If that is not given in the question, take Q as positive. Is that okay now? If that is not given in the question, take Q as positive. It's okay, simple. You can remove the negative sign. That's a plus for you. Okay? And you have a cube like this. You have a cube like this. For that, the method will be like this. You have to find the distance to the center. You have to find the distance to the center. How can you do that? I will show you how you can find the distance to the center. Look here. The side is B. Right? The side is B. So, what is this? Diagonal of the square or diagonal of the face. You have to find diagonal of the face now. Diagonal of face of square. Face of square. Diagonal of face of square. What is that? That's, you can take it as D. You can take it as D or you take it as D. So what is this? What is this D? What is this D? What is the value of D? What is the diagonal of a square? What is the diagonal of a square? What is the diagonal of a square? What is diagonal of a square? Is one side is given root 2b. Root 2b. Root 2b will be the diagonal of the, like this. Here b, here also will be b. Then this will be what? Root of b square plus b square. That will be root of 2b square. What is that? Root 2b. So diagonal of the face or diagonal of the square will be what? Root 2b. Is that okay? Then that is root 2b. Root 2b. So diagonal of the face is root 2b.
Yes, sir.
You can take it as b. Is that okay?
Yeah.
Now you can find the diagonal of the square. Sorry, diagonal of the cube. This is the first idea. Now you can find the diagonal of the cube. Diagonal of the cube. Diagonal of the cube. You can take that in another way. I'm calling it as r dash. R dash. You have an equation for diagonal of cube. You may not have know that. I will give you that equation. That equation is root of d square plus b square. That's diagonal of the cube. That will be the diagonal of the cube from one end to the other end. That's the diagonal of the cube. D square plus b square. What is d square? What is d square? What is d? D is the diagonal of the square. If you are taking the square of it, that will be like this: root 2d the whole square plus b square. Right? Then what will be the value? If you are taking the root 2 square, that will be 2. 2b square plus b square. That will be root of 2b square plus 2b. Sorry, 2b square plus b square. What will be that? That will be 3b square. Is that okay? Is that okay? That will be 3b square. Okay. So what will be the final value? Root 3. What is the square root of b square? Square root of b square. Square root of b square will be b. Square root of b square will be b. So root 3b. What is that? Root 3b. Now you have what? Diagonal of the cube. What will be the center of the cube? Yeah. This is the diagonal of the cube. Then what will be the center of the cube or distance from the vertex? Distance from the vertex to the center. What will be that?
3 by 2.
To the center. You can call it as R. That's why I called it R dash. Well, okay, now? R will be what? R will be half of R dash. R will be half of R dash. What is R dash? Root 3b. So R will be what? Root 3b by 2. That's R. Root 3b by 2. You go to your answer. You have R now. You have R now. What will be the potential? What will be the value of potential? What will be the value of potential?
KQ by
Yeah.
3.
Potential at the center. I will write potential at the center. Potential at the center. What is potential at the center? V is equal to 1 by 4 pi epsilon naught
8
charge by distance. How many charges are there?
8
8 charges are there. So 8 into Q. 8 into Q. 8 charges are there. Right? So that's due to this charge will be 1 by 4 pi epsilon naught Q by R. Due to second charge will be 1 by 4 pi epsilon naught Q by R. How many of them? 8 of them. That's why 8 into. Is that okay? 8 into Q, or I will write it like this: 8 into 1 by 4 pi epsilon naught Q by R. What is the R? What is the R?
Root 3 by
R root 3 B by 2. Root 3 B by 2. 2 will be coming to the top. Then 8 into 2, 1 by 4 pi epsilon naught Q divided by root 3 B. What is 8 into 2? 16. Or you can cut it from here. That will be 2. 2 into 2 will be 4. So 4Q divided by pi epsilon naught root 3 B. Or you can give it a style. That will be 4Q divided by root 3 B pi epsilon. Whatever. Everything is okay. Every form is okay. This is what? This is the potential at the center. You got it? This is the potential at the center. This is the potential at the center. You got it now? Now you have the potential at the center. What is the electric field at the center? What is the electric field at the center? What will be the electric field at the center? There will be electric field due to this Q here, but that will be cancelled with this Q. And electric field due to this Q will be cancelled with this Q. Electric field due to this Q will be cancelled at this Q. Electric field due to this Q will be cancelled at this Q. Everything is cancelled, right? Then net electric field will be 0. There will not be electric field at the center. Can you understand that? There will not be electric field at the center due to symmetry. You can answer it like that. Due to symmetry of the cube. Due to symmetry of the cube. Due to symmetry of the cube. The net electric field. Net electric field at the center. Net electric field at the center is 0. Net electric field at the center is 0. That's our answer. Due to symmetry of the cube, the net electric field at the center is 0. Due to symmetry of this cube, the net electric field at the center is 0. I will repeat it again. Repeat this solution. Just write the note. I will repeat it. Electric potential, example question. We are discussing example question. That is question from NCERT. And the first question is what? You have given 8 charges. They are not saying 8 charges. They are saying there is a cube and you will be given, you are given charges and you are placing that charges in 8 vertices or vertices of a cube. How many vertices a cube has? 8 vertices. So in 8 vertices, there is a cube distributed in a way, and this is the center of the cube. You have to find the total potential and the electric field at the center. How can you do that? First, you need the distance. If you want to find the distance, diagonal of the face, you have to find the diagonal of the face first. What is that? Root 2b. And now you have to find the diagonal of the cube. What will be that? That will be r dash root of d square plus d square. Is that okay? And find that, you will get something. And take half of it. You will get the center. You will get the center. Right? Take half of the diagonal of the cube. You will get center. Diagonal of the cube is this, right? Diagonal of the cube will be this. This is the diagonal of the cube. From this cube to this. Right? And the center will be half of it. So, okay, center will be half of it. So, center is r dash divided by half of the diagonal. So, you are getting this r. Now, you have r. You can find potential. What will be that? 1 by 4 pi epsilon naught q by r is the value of potential. But there is 8 charges. Due to these 8 charges, there will be 8 potentials. When you are adding them, they are the same. So, you can just multiply it with the 8. You can just multiply it with 8. So 8 into that. 8 into that. Is that okay? Just cut it and you will get an answer. That's the first question. And look at the next question. Next question. Second one. Look at the second question now. What is the second question? A positively charged particle is released from rest. Positively charged particle is released from rest in a uniform electric field. The electric potential energy of the charge. What happens to electric potential energy? That is the question. What happens to electric potential energy? That question. Can you give me an answer? Can you give me an answer for that? I am moving to the next page. Can you give me an answer for that? The second question. The second question. Look at the second question. What is it? The second question. What is the second question?
A positive charge.
A positively charged particle is released from rest in a uniform electric field. That means there is a uniform electric field like this. There is a uniform electric field like this. This is what? This is uniform electric field. Is that okay? There is a uniform electric field. And you are releasing a positive charge from rest. What will happen to this? Yeah. You are taking a positive charge and you are releasing that positive charge from it. What will happen to it? Electric field means there will be a positive charge here, there will be a negative potential here. That's why the electric field is like this. Okay? If you are releasing a positive charge from rest, that means what will happen to this?
It won't remain constant.
Huh?
It won't remain constant.
No. Yeah. What will happen to that electric charge? What will happen to it?
Will it decrease?
I'm just asking what is happening to this charge?
Will move around.
It will accelerate through this electric field. It will move along because there is a positive charge, it will repel it. There is a negative charge, it will attract it. That means this positive charge will be accelerated through this electric field. Right? Did you understand that? Because this is a uniform electric field, it will get a constant velocity. It's a uniform electric field, it will get a constant velocity. So the charge will be moving like this. What happens to that potential energy of that charge? That is not question. What is the value of potential energy when it is at rest? At rest, what will be? No, potential energy will be maximum when it is at rest. Got it? Potential energy will be maximum when it is rest. The potential energy of my phone is maximum now. And when I am taking this to a height, when I am placing it here, when I am placing my phone here, the potential energy of my phone is now maximum. When it falls down, what will happen? That potential energy will be converted to kinetic energy, right? Then that potential energy will be decreasing. That potential energy will be converted to kinetic energy. Kinetic energy will be decreasing, potential energy will be decreasing. What will happen then? What is at the rest? At the rest, potential energy is maximum. Potential energy is maximum. When the charge is released, what will happen? When the charge released, what will happen?
Moves along.
It moves in the direction of electric field. It moves in the direction of electric field. In the direction of electric field. Got it? In the direction of electric field. Okay. What happens to potential energy? Potential energy is converted to, right? Potential energy is converted to kinetic energy. That means potential energy will be decreasing, right? That means potential energy will be decreasing. This is the answer. What is the option? Potential energy will be decreasing. What is that option? C. Decreases because the charge moves along the electric. Then okay. I'll be stopping here. I'll be stopping here. I have only 15 minutes left. I will start with the second chapter, third chapter. I will start the third chapter. I will start the third chapter. I can just give you one or two ideas from that first third chapter with this 15 minutes. Okay. I will repeat it. What is it? At rest, potential energy is maximum. Potential energy will be maximum at rest. When the charge is released, what will happen to it? It moves in the direction of electric field. It moves in the direction of electric field. And potential energy is converted to kinetic energy. And potential energy will be decreased. So potential energy is decreasing. That's the idea we got from right? Can I move to the next chapter? I'm moving to the next chapter. Our third chapter is current electricity. Current electricity. Current electricity. What is it? Current electricity. Are you here? Betsy, Joseph, Neha. Are you here? Yeah, okay. Current electricity. In this chapter, you will be studying about moving charges. In this chapter, you will be studying about moving charges in the form of the electrostatics. We have completed electrostatics. Then okay, we have completed the electrostatics now. Now we are going to study what is happening to the charge when it is moving. That's what current electricity. Current electricity. What is the meaning of this current? What is the literal meaning of current? Flow. No, flow. Current is what? Just flow. Current electricity means flow of charge. Flow of charge. Now, I will introduce you to the first term that we are going to study in this chapter. That is electric current. Electric current. You can take the lecture note from it. Electric current. Electric current is represented with this letter I because intensity of electric current. This is a first chapter, Natasha. You will understand it. Right? Electric current. What is that? I. Intensity of electric current. So that's it. And what is this electric current? If you are taking a conductor, and considering the conductor, and there will be charges. There is charges moving along that conductor, moving inside that of conductor, and the charge is moving through this conductor. What is moving through this conductor? Charge is moving through this conductor. If you are taking one portion or one point in it, there will be charge flow through that point. Right? Charge flow through that point. Just take the rate of charge, rate of flow of charge, you will get current. So what is current? Current is the rate of flow of charge. It is the amount of charge. What is that? That is amount of charge flowing, amount of charge flowing through the conductor, in unit time. Got it? In unit time. Yeah, you don't need this figure in unit time. Is that okay? Now that's current. From the definition, you can have the equation for current. What will be the equation for current? Amount of charge flowing through the conductor in unit time. If you want some quantity in unit time, what do you have to do? Divide that quantity with the time. You will get in unit time. You will get that quantity, change of that quantity in unit time. So that will be Q by T, charge by time. That will be what? Charge by time. Equipment is the charge by time. That's the equation. Got it? So current is having an equation, charge by time. This is actually the equation for steady current. What is that? Steady current. What is this steady current? What is the meaning of steady current? The flow of charge is steady. If the flow of charge is steady, then the current will be steady current. If the flow of charge is not steady, what will be there? Then there will be variable current. There will be variable current. The current is variable. the current is not steady, non-steady. If flow of charge is non-steady, if flow of charge is non-steady, then what will be that? Yeah, I will be equal to, you have to take a very small charge. A very small charge. That will be dq divided by how much time does it take to cross a point? That small charge will take small time, right? That small charge will take small time. Then dq by dt will be the equation. dq is what? Small charge. dq is what? Small time. So this is the equation. I will be equal to dq by dt. I will be equal to what? dq by dt. Now you have a definition. What is that definition? Rate of change of charge. Roughly, what is current? Current is what? Rate of flow of, not rate of change of flow, rate of flow of charge. That's what current is. Rate of flow of charge. Is that okay now? Now you have charge. And what is the equation? What is the unit of it? What is the unit? What is the unit?
Ampere.
Yeah. What is the unit? From this equation, what will be the unit? Yeah. Coulomb per second will be the unit. Coulomb per second will be the unit. SI unit is, you know that, you have studied that in 11th standard. What is the SI unit of current? Ampere. SI unit of current is ampere. Symbol is capital A. Symbol is what? Capital A. SI unit of current is ampere. Symbol is capital A. You're okay now? Right? Okay. So that's about current. And one another idea. Is current scalar or vector? Current is a scalar quantity. Scalar quantity. Current is a scalar quantity. Current is scalar quantity. Scalar quantity. But current has direction, right? But current has direction. When we are constructing a circuit like this, current has a direction. Current is from positive to negative, like this. Current has direction. Why current is a vector quantity? Sorry, why current is a scalar quantity then?
It has direction or
Of course, it has an active. It is the value of it. What is it? What is the definition of vector? Actual definition of vector.
First direction.
A quantity that has magnitude and direction, and it obeys the law of vectors. It obeys the law of vectors. Then only it will be a vector. Current has magnitude and current has direction, but it does not obey the laws of vector addition. Got it? Force is having magnitude and direction. It obeys the laws of vector addition. You can add force by considering it as vector. Okay, force is a vector, but you cannot add current in the same way you can add force. Right? Current is not following laws of vector addition. You got it? That's why current is scalar. Okay now? So current is scalar quantity. And the next idea about current. How can you measure current? That is the next. How can you measure current? You can use ammeter. It's a device. What is that? Ammeter. Current is used to, ammeter is used to measure current. Ammeter. Ammeter is what? Device. Device used for the measurement of current. Ammeter is what? Used for the measurement of current. Got it? What is the symbol for ammeter? Do you remember what is the symbol for ammeter? Symbol for ammeter will be A inner circle. A inner circle. It is always connected in series in a circuit. Always connected in series. Always connected in series. Always connected in series. Always connected in series. Okay, always connected in series. Then the next device. Next device is galvanometer. Galvanometer. Do you remember what was a galvanometer? What was galvanometer? Do you remember that? What is galvanometer? No.
So that is one picture.
That's a device used for the detection of current. Used for the device. Used for the device. Used for the detection and direction. Detection and direction. It will show you the direction of current. Direction of current. Detection and direction of current. Okay now? It is also connected in series. If you want to measure current, you have to connect it in series. If you have to detect current, you have to measure, you have to connect it in series. So the galvanometer is also connected in what? Connected in series. Galvanometer is also connected in series. Galvanometer also is connected in series. Okay. What is the direction of current? What is the direction of current? From which potential to which potential? Current is always from higher potential to lower potential. What is the higher potential?
Positive.
Positive will be the higher potential. So current flow will be from where to where? Current flows from which potential to which potential? Current flows from positive to negative. From positive to negative. Current flows from positive to negative. Is that okay? Current flows from positive. Now I'll give you some trivia. Trivia means you don't have to study that. You don't have to study that. First one is household current. Household current will be here. Household current.
Alternate.
That's alternating current. Household current will be in the range of 1 to 4 ampere. It will be no. It will be connected fast.
So,
You don't need. Or if you like that, you can do it. Household current will be in the range of 1 to 4 ampere. Is that okay? And there is lightning. Let's see. There is lightning. There is lightning. What is the range of current in lightning? Lightning current will be 10 raised to 4. 10 raised to 4. 10 raised to 4 ampere range. It will be in the range of 10 raised to 4 ampere. This is enough to kill us. This 1 to 4 ampere is enough to kill us. But if we are struck with the lightning, that will be enough. That's it. That's a feeling. That's it. Malayalam. Only Arfad is here with only Arfad. Lightning has a range 10 raised to 4. And do you know about the outcodes? What are outcodes? What are outcodes? Outcodes are electric pulses. Do you know that? They are electric pulses, electrical signal, electrical energy, electrical signal. That will be in microampere range. Nerve signals. Nerve signals will be in microampere range. Nerve signals will be in microampere range. Nerve signals will be in microampere range. Is that okay?
Yes.
Everything about current is okay?
Yes.
Can I move to the next thing? That's current density. The next thing is current density. Current density. Current density is represented with J. What is current density? It is represented with J. Current density, I will give you the equation first. Current density is I by A. Now, give me a definition. What is current density?
A by M square.
What is current density? Current density.
So current.
Is the current per unit area. What is current density? Current passing through the conductor per unit area. Current per unit area. What is current density? What is current density? Current through unit area. Current through unit area. That will be J. J is what? I by A. I by A. Current flowing through unit area. Current through unit area. Give me the equation, the unit for it. Unit will be what? Unit of current density will be what? Here you have ampere divided by what is A? A is area per meter square. Ampere per meter square is 1 unit. Ampere per meter square is 1 unit. Or you can have another unit also. Current has 1 unit also. What is that? Coulomb per second by meter square. Then what will be that unit? This meter square will be coming to the denominator. Then that will be what? Coulomb per second meter square. Coulomb per second meter square. This also is a unit of current density. This also is a unit of current density. This also is a unit of current density. Did you understand that? What is current density? It is having this equation J is equal to I by A. It is easy to study that way. First study the equation, then the definition. That is the easy method. J is equal to I by A. Now convert that into words. What will be that? Current flowing through a conductor in current flowing through unit area. Current flowing through unit area. What is that? That's current density. So unit will be what? Ampere per meter square. Another unit is coulomb per second meter square. You have to understand something. This current density is a vector. Current density is a vector quantity. Current density is a vector quantity. Current density is a vector quantity. Our time is up. We will wind up our session here. Right? In the next class, we will do 2 or 3 questions from the previous worksheets. And after that, we will continue with this step. Right? Only the practice of questions or only the chapters will, both of the methods is not okay. We have to take them compared. And how can we arrange this? And by all, Betsy, Joseph, Neha. Bye all. Bye. See you later.
But